Hi everybody, Scott Stanchfield here. Let's take a deeper dive into how you can do layouts in Jetpack Compose. Now when I'm talking about a layout, I'm talking about some kind of an algorithm that decides where to place things for you based on some hints that you can provide it. Each of the components might have some hints attached to them, or maybe just the algorithm just depends on the number or the types of data coming into it. Now we've already seen in our previous example a little form that looked kind of like this. We used a column to just put different text fields in. So we had like a text here and a text field, text here, text field, and so on. And by doing that, we get a pretty nice little form that's easily scrollable. But it doesn't take advantage of screen space terribly well. If we wanted to take advantage of screen space better, we might want to say if there's enough room, let's switch to a layout that looks more like this, where we'd have our labels next to the text fields. So we'd have label field, label field, label field, and so on. And we create a nice looking little form like this. So what we're going to concentrate on in this lecture is taking a look at ways to implement this kind of a layout using different approaches in Jetpack Compose. So first of all, what I'd like to start off, let's look at this as a single column where we have one column for everything, and then a bunch of rows. So we're going to say that's a row, that's a row, that's a row. Each of these lines is a row, and it's going to have two components in it, the text and then the text field. So let's see what that's going to look like. And I'm going to simplify things here a little bit. I'm not going to actually make any of these controls actually work. The data isn't actually going to be updatable. We're just using this to see things on the screen. So to start with, let's create a couple little composables here. So we'll have a label that we'll call it here. And I'm going to say text is a string. And we're not going to extract the strings here. We're just going to hardwire things just so it's easier to work through this example. And let's add in a modifier in case we need it. So modifier. And I'm going to default that to just modifier by itself, so no specific modifier coming in there. And I imported the wrong modifier. Let's try that again. Make sure that when you're importing this, you get the Android X Compose UE modifier. And whoops, still have the other modifier up there. So let's try this one more time. And there, that's much better. So we'll start off with this guy, and he's just going to say, I'm going to put text on the screen. Text is going to be the text coming in, and we will pass the modifier in as well. So if the user happened to pass it in, we'll use the one passed in. Otherwise, we're just going to use that starting point modifier, which doesn't have anything in it to start with. Now I also want to put a style in with this guy. And I will say material theme, typography, and for the label we'll use H6 like we did before. And let's do the same kind of thing for, I'll call it edit. And we have the text coming in there, not going to bother passing out the changes. Again, this isn't going to be an active UE, we're just using it for the way things look. So we'll have that there, and we'll say on value change equals, we're not going to do anything. And this should actually be value. And we'll make this be an H5. And what is the unhappy unresolved reference text field? I might have to import it. And oh, it's text style for text field. There we go. So now we have a couple little simple helper guys here. And let's create our first layout. I'm going to create each of these layouts in a separate composable function just so we can kind of swap them in and out. So I'm going to say composable, fun, and we'll say form using column with rows. So we'll be a little bit explicit on what we're trying to do here. So we're going to start off with a single column at the top. And then inside, we're going to have a row for each individual line that we're having there. So we're going to have a label, first name, and let's go ahead and put in a edit with Scott, and then let's see, last name, age, street, city, state, zip. Let's put those in there. So it's going to be zip 10101, and this is going to be state, New York, and this is going to be city, New York. And this is going to be street. I don't know why I'm going from the bottom up. And then for, let's see, we have age, put in 54, and this is going to be last name. There we go. So that should give us a nice simple little form here. Let's see what that actually looks like when we put in the form. Why is he not? Oh, not at sign. Form using column with rows. There we go. And let's try running him and see how it looks. And obviously I've done something a little bit wrong. Let's take a look. Well, turns out I put everything in a single row. Really not what we wanted to do. So I'm going to break that up. Whoops. And then let's add in, I can just come from the bottom here with him. And let's see if that makes things look a little bit better. So we'll rerun him. And there we go. Now, there's a few little issues with this one here. I'd like to add some padding. I'd also like to make these text fields stretch out so they go to the end. So let's fix those up first, and then we'll talk about the other issues. So we're going to say modifier.padding 8.dp. So that way we'll get a little bit of padding around things that lets the UI breathe a little bit more there. And then we want to make sure that this edit text here, the text field, is going to fill the max width. So he's just going to expand more. Or actually, let's we should really use a weight of 1 there. Well, that would imply that he's only inside of a row. So let's just use the fill, which should fill in the rest of the row there. Let's go ahead and try that. And there we go. So we'll see that they're actually stretching to where they need to be appropriately. You have to be careful with using fill max width, because if you use it on a component that comes first, it's going to fill up, and then any components after aren't going to have any room left over. Ideally, we want to use this as a weight. In order to do that, we would have to make sure that we make this edit have a row scope passed in. So what we do there is you could actually make this an extension function on row scope, which would then give us weight as an option. So I could say 1F. However, that means we can only use this edit inside of a row. We couldn't use it anywhere else. But let me show you what this would look like when we run it. Should end up looking the same. But it gives you a little more flexibility for really specifying it correctly. Okay, so now we're seeing that. So a couple issues here. Let's take a look at each of these labels and the text field here. You notice how the label's kind of high? We'd really like to kind of center that. That would look a little bit nicer there. So what we're going to do on our rows, we're going to specify vertical alignment. And we can say alignment center vertically. And what that'll do is all the components inside that row are going to be centered through a center line, through a midline that goes through all of them. And that actually should make things look quite a bit nicer. I'm going to go ahead and copy that and paste them into all these ones down here. And let's rerun it. That should improve that a little bit. And there we go. That's much, much better. But let's talk about the elephant in the room here. Notice how all of these fields are like jaggedy all over the place. We really want them to line up. It'll give you a much better visual appearance. And we can't do that here because each of these rows is completely independent from each other. They don't have any information about the size of the labels from previous rows. So it can't line things up. So we need to somehow say, I want to divide here between the labels and the text fields. And so the natural feeling there is, well, why don't we swap this? Why don't we make a row with 2 columns inside of it? And maybe that will work. So let's give that a try. So I'm going to make a copy of this function. And let's call this form using row with columns. And we're going to start at the top level, a row. And then inside, we're going to have two columns. So I'm going to have one column for the labels and one column for the edit texts. Now let's just get rid of some of this stuff in here. So we'll move the label up. See if I can do this a little bit more efficiently. So there's my labels. And then I can move my edits up. Now, of course, now we have that issue where edit can only be called inside of a row. Now, we could, of course, change this to be a column, but then the first one's going to break. So let's change it back to the approach that we had to start with. Let's comment that out and leave it in so you could see that that was an option. And we'll say only if used in row scope or column scope. And so now we'll change this to be again, the film max width so that it'll take up the rest of the space. Because we happen to be using this last in the row, that'll be perfectly fine. So now we have these two columns. And let's use this guy now. And see what that looks like. Ooh, boy. So we have a few issues with this one. It looks like we got our line down the middle just right, and we have all of our text fields showing up, but now the labels aren't taking much space. And what's going on here is that each of these columns, this column is only taking up the space that he actually needs, and this column's taking up the space he needs. And obviously, the text fields are taking up more space. So when they're displayed, they take more space vertically. The labels aren't getting spaced out more. Now, what we can do to help this is we can actually force these to get spaced out. And there's some spacing options we can use on those. These spacing options I'm going to use are called arrangement. It's once we've aligned the pieces inside of the layout. So like before we had that horizontal alignment, or the vertical alignment with the line through the center. Instead of that, after that's taken care of, we're going to say how we want to space them apart. We're going to arrange them with inside. So if we come down to each of these columns, what I want to do is say vertical arrangement equals arrangement and specify one of these types of guys. And there's several options in here. The space ones are the ones that we want to do. If we use bottom, center, or top, it just takes the group like we have right now and shifts that group to the bottom or the center or the top. Right now, it's basically the equivalent of setting it up to the top. They're all grouped and they shift to the top like that. Now, if instead we use one of these space options, it'll put space between them, it'll put space around them, or it'll space them evenly. Let's take a look at what each one of these look like. I'm going to say space between. And let's do the same thing down here. Like that. And let's see what that looks like. Doesn't look like anything's changed. Now let's think about why that might be. And what might be a good way to start taking a look at this is let's use the layout inspector down here. If I click on him, it's going to read that user interface. And here's what the user interface looks like. Now, if you notice, the box here that's surrounding this isn't taking up that whole vertical space. And this one is. So what we really want to do is make sure that both of these, this column here and this column here, are taking up the same amount of vertical space. And then we might have a shot at this. Now, just a little note on this. You can also, if you hit this little button here, well, I need to hit this refresh button first. Usually that works. Well, this button normally shows kind of a three-dimensional view of things. For some reason, it's not refreshing. If I click on this and click off of it, there we go. So what I had to do is I clicked on the auto refresh, then clicked it off, and then refreshed, and now this button's available. But the 3D mode lets you kind of, whoops, let's get rid of the pan there. It lets you rotate a little bit there. So you can see how the layering is working on these. And this might be useful if you're having trouble figuring out how different pieces are layered inside other pieces. And we can move the spacing a little bit. Over here on the side, it also shows you a view of what that tree inside Jetpack Compose looks like. So you can see how each of the nodes are resolved into the different descriptive elements used to set up the user interface here. So you can see we have our theme at the top. We have this form, which is just a row. And so it gives you kind of a nice view of how the nesting works. It'll also show you over here different parameters, including the modifier that was passed into that component there. And if you click on the component inside here, you can see which component he is. If we go back to our flat view, it might be a little easier to see how things work here. So there's my text field, our modifier with our 8dp. This guy up here is the column, and then the column there. And you can let you kind of walk through and take a look at the parameters if any of those are the issues. But this has actually helped us out now because we can see that this column here is shorter than this column here. So we want to make those actually work together. So let's see. For the row, actually for the column here, we want to put in a modifier equals modifier dot fill max height. We're going to match the height of the row that we're dealing with. And the row should be big enough to hold both of these columns. Let's try that out. And now we can see that we're getting a little closer on the spacing. But what we did with space between is it starts off the components right at the top and then puts space in between them all, but not on the outsides of them. Our other options here are space evenly and space around. Now, space around is really what we're going to want to have happen here. But let's take a look at space evenly. See how he looks. And we'll run him. And now we can see that things are looking a little bit better there. There's still some wonkiness as far as the space for the labels here versus the space for the text fields. So it's closer, it's on the right track. But let's take another look at the layout inspector here. Now if we take a look at now these columns, they're taking up the entire space instead of just as much space as they need. And trying to get these rows and columns to set up so they just take up as much space as they need but then space out evenly inside really isn't going to quite work for us here. Let's go back to here. Let's change this to space around just so we can see the lineup happening okay. And then we'll run him. And now we'll see that it looks like things are lining up pretty good with the space around, but everything is still being spaced out too much. So trying to get this to work is going to be a little tricky there. Let's try putting a scroll on this as well. I'm going to say vertical scroll. Remember scroll state. And we'll run that. And now we're back to this. Oy! Because now the row doesn't take up a fixed amount of space on the screen. It's going to scroll to be how much it needs. So it seems like no matter what we do, something isn't going to quite work right. And if we had too many items for the screen, we're not going to be able to scroll and see them and still have things line up. So this approach really isn't going to work too well. It seemed like there was some possibilities there, but it just really isn't going to work. So at this point, we really need the help of a layout manager to tell us the associations between things. And from the old version of views inside Android, you would use something called a constraint layout to do this efficiently. there were other types of layouts you could use. Like in particular, there was a table layout, which would have been perfect for this. But we don't have that table layout in Jetpack Compose. So constraint layout might work. And one thing that I want to caution you on this is it was mainly used in the old view approach for efficiency. The way that they've done things in Jetpack Compose, we don't have those efficiency concerns. And the concerns before were if you nested layouts pretty deeply, the calculation for figuring out how things should be sized ends up being exponential. Because you'd start off at the top level, he would ask his nested things to figure out their layouts, who would ask their nested things to figure out their layouts. And you get this kind of recursive down to figure out all the individual layout pieces as we build up to figure out what size the parent should be. And it was really, really awful sometimes. So constraint layout was trying to do everything at once. And it ends up being a little complex because of that. We're going to give it a try here and see if we can actually hope that this will help us. Let's say at composable. And we'll say fun form using constraint layout. So the idea with a constraint layout is that each component is constrained by linking it to other components in the layout, or by linking it to the bounds of the parent layout. So we're going to start off thinking about how we constrain things. And in order to do those constraints, we need to assign a special reference for each component that we want to have constrained, so other components can reference it. It's kind of like an ID, and we could use a string ID for it. There's a form of this that uses string IDs, but that's not quite as type safe. So we're going to use a form where we're actually going to create a set of refs first and then associate them to each of the items inside the layout. To do this, we're going to start off with a constraint layout. Oh, before we can do that, we actually need to import this guy. So I just did a search for constraint layout in Compose and ended up with this page. And this is going to talk about how you're going to import the dependency for it. And constraint layout is actually versioned separately from Jetpack Compose, so just be aware of that. I'm going to go ahead and grab this implementation here, and then we will come over to our app, build.gradle, and in his dependencies, I'm going to paste him in there. And I'm going to set this up a little later so that it actually is added as part of the library implementation here that's bundled in. I may have already done that. And I paused the video and checked. Nope, I did not yet. So I'm going to pull that into, might as well do it right now. Let's grab him. And I'm going to add him in here. Let's go ahead and put this here. And we will say constraint layout equals that guy there. And that should set him up as a dependency library. I'm also going to add that constraint layout to the base bundle. I'll put it right there. Kind of like that. And that should set it up so it can import okay. Coming back over to the project, I can now delete that line because it should be brought in as part of this bundle. And let's sync it and see what happens. Okay, I paused the video while it was syncing so you didn't have to see all that. And let's go back to our main activity now and try using this. So I'm going to say constraint layout. You'll notice that now it's actually showing up as a composable function. And inside of this constraint layout, I'm going to set up my modifier. Oops, actually I want to do that in parens up here. And we'll give it some padding around, so 8.dp. And I'm going to say fill max width. And I'm going to say wrap content height. I just want to be as tall as I need to be for the stuff inside there. And we're going to add in our vertical scroll with remembering the scroll state. So that's just the basic setup for what's going on around the constraint layout. Now inside of it, I'm going to set up some references here. So I'm going to start off by saying L1, L2, L3, L4, L5, L6, L7. This is tedious. E1, E2, E3, E4, E5, E6, E6. Oops, I missed the 6. E7, because I'm going to have 7 labels and 7 edit texts. Could have just called those T, but whatever. So I have 7 labels in that. I'm going to say equals create refs. And what this is called is this is a destructuring declaration in Kotlin, where whatever object is being returned by create refs has a bunch of functions inside of it called component 1, component 2, component 3, and so on. And when we're doing this setup, L1 gets assigned to whatever component 1 returns, L2 is whatever component 2 returns, L3, component 3, and so on and so on. And that way we can have this one function call create all of these objects for us automatically. It's kind of nifty. So that sets things up there. Now what I'd like to also do is think about how I can divide the labels from the text fields. So we're going to create a vertical barrier between the labels and the text fields. This barrier is going to push itself over as much as needed for all of those labels, which means it'll give us a nice straight line where all of the text fields can start. So I'm going to say val vertical barrier. Actually, I can just call it barrier because I only need one. Equals create end barriers. This is going to be a barrier that starts at the end of a bunch of components. And then we pass in the components that it's going to be at the end of. So it's going to be label 1, label 2, label 3, label 4, label 5, 6, and label 7. So this is going to be to the end of all of these labels. Now we also want to deal with spacing the labels and the text fields out properly. So we're going to create vertical chains for these. And all the chain does is set it up so that the top and bottom references from each component refer to each other. So if you have, let's say we had 3 labels on the screen. Let's say label 1, label 2, and label 3. What it's going to do is say link link top to parent. So we're going to start with having that be at the top at the parent there, and bottom to L2. And this is going to be link top to L1, bottom to L3, and this links top to L2, bottom to parent. So this is basically what the vertical chain is going to set up for you. And when you do this in a constraint layout, it spaces them out the same way that we saw those labels spaced out when we did the space around. So they should line up nicely with the text fields. So we'll do that by saying create vertical chain and pass in the things that we want. So L1, L2, L3, L4, L5, L6, L7. And then we're going to pass in a chain style. I'm going to call it spread. Spread inside is similar to the one where it didn't have space above or below. Spread is going to make sure that it has space around things nicely. And we'll do the same thing for E1, E2, E3, E4, E5, E6, and E7. And that should do this kind of linking for us automatically. That's a lot less for us to type later on. We could do it by hand, but it's kind of painful doing it by hand. So we're going to do it in those little shortcuts. And now we're actually going to set up the text fields and the edit texts here. So let's start off with our label. And we're going to have him say text is Scott. And what else do we need on him? Modifier dot constrain as, and then we're going to pass in which identifier we want to use for him. So he's going to be L1. And then we pass in the actual constraint that we're going to set up between the different components. So I'm going to say start dot link to parent dot start. This tells us that the beginning of this element is going to match the beginning of the parent, so the containing box. So that one wasn't too bad. Let's do something similar for our, what did I call that? Edit. And we have the text passed in, And this one is going to say start is going to link to that barrier. So we want him to start after the barrier who's been pushed all the way past all the labels. And then we're going to say end link to parent.end. So he should hit the end there. Now what this is going to do is make him float between the barrier and the end. So we want to make sure that we set him up so that he will actually stretch between those 2 points. To do that, we can say width equals dimension fill to constraints. So that's going to say take up as much space as I can between those constraints. Now this doesn't take into account padding. And we can add padding in here by saying before the barrier leave 8 spaces. Or I can use my normal padding and say that the component has padding around it. I'm going to go ahead and use my normal padding. So I can say padding 8.dp before I constrain as. And now we have an edit there. Now we're going to want to do the same kind of padding thing up here with this guy. Let's say padding 8.dp. And actually, did I already do the padding in there in the label? Yes, I already have that. So I just want to make sure I pass the modifier in for him. So I can get rid of the padding because he's already taken care of. And that should be okay. Now we're going to have to do this for all of these fields. So I'm looking at this and hey, there's a lot of commonality here. And we can probably make this a little bit simpler to type. So let's do a kind of customization of our edit field. Let's go down to where we have our edit. There he is. I'm going to make a copy of him. And let's call this constrained edit. So we're going to use it inside of a constraint layout. So in order to use it inside of there, I'm going to pass in a constraint layout scope as my receiver. That's going to give me access to that constraint as. Otherwise, I won't be able to say constraint as. And then down here, I can say dot constraint as, but I need that reference passed in. So let's pass the reference in here as well. So I'm going to say pass in that reference, which is a constrained layout reference. And I'm going to say constraint as ref. And then put my curly braces in to do my constraint work. So one of the things I want to do with this edit text is say width equals dimension fill to constraints. Don't need these guys anymore. But I'm going to need to have some different constraints based on wherever I am inside the layout. So what I'm going to do is pass in a constraint block, I'm going to call it, which is going to be for a constraint scope unit. So when I'm inside this constraint as, I get passed as this a constraint scope. I'm going to do the same thing here by passing in this function. And now I can say constraint block to execute whatever he needs there. And let's make this be a uppercase modifier since I'm not passing a normal modifier in. And so now you'll see that in the constraint as, it gets past that this constraint scope, which means I can just call the constraint block, passing that constraint scope to him, and he can call all those other functions he needs to set things up. One other thing I want to do is I want to try a different type of text field just so you can see how that looks. I'm going to use an outlined text field. And he'll just have a slightly different appearance than we've seen so far. Now let's do the same type of thing for our text. So here's our normal label up here. We'll make a constrained label. And I can have a constrained layout scope in front of him. I'm going to pass in a ref, which is a constrained layout reference. I'm going to pass in our constraint block, same type of thing we did before. And then down here we'll say modifier dot padding dot constraint as the ref, call our constraint block. Actually, I don't need to, because we don't need to have anything extra we're putting in here, we can just go ahead and pass that constraint block in directly. And there we go. if we take a look at this constraint as, you'll see that he takes that constraint block the same way. Oh, he called it constraint block. That's why it wasn't liking it. So this now is a little text field that's going to work for us as well. So let's go up and use these, which should shorten our code a little bit. Where did I have that? Here he is. So now if I have a constrained label, I'm going to have that ref. I'm just going to type in the L1 and Scott, and then the curly brace. And there we go. And that saves quite a bit of code there. It's a little bit more readable, I think. And we can do the same kind of thing here for a constrained edit. I'm going to pass in our ref of E1 and Scott. Oh, this actually should be first name. And then we'll pass in his constraints. And now we have two of them set up. Now you can already see this is going to be a lot of work to set this up. But this one should work a lot better. It's not going to be our end game, but this is actually a pretty decent way to go about this. So rather than sit here and type this for the next half an hour, I'm just going to paste in what I did earlier on this. I used to call it vertical barrier. I'm going to just call it barrier because I realized I don't have any other barriers. I can just say barrier. And now if we take a look at this, these are all pretty similar here. So we're going to say that each of the labels, they're just linked to the start. So that's the only thing that they care about, is that they're anchored to that side, the left side of the screen. And each of the edit fields, they're linked to the barrier and linked to the end. So very, very similar. So now looking at this, we could actually even do these inside that constrained edit, since it's the exact same thing every single time. We would have to pass the barrier in as well. I'm not going to go to that level of detail. I really kind of want to keep it spaced out like this. You could see if you had other constraints you want to set up, you could put them in these blocks. But if we wanted to and we noticed, hey, these are all exactly the same, we could go ahead and define that as part of constrained label. And that would be a nice reduction of code here. So now we got all this set up here. Let's try running this and see what happens. So this is form using constraint layout. And let's run that. Ta-da! So now we have something that's looking quite a bit better there. There's still a little bit of spacing issues on this that we'd need to tweak in that layout just to get them to line up right, because you'll see that some of them seem to line up okay. Some of them are just a little bit off there. But if we tweak around with it, we can actually make that look better. And I actually like these text fields quite a bit better. They don't have that dark background to them. So we're getting closer. And notice also that these are spaced out and leave some space at the bottom, which we didn't get when we put that 2 rows inside of a column approach. So this starts to get to the right approach, but take a look at all that code just to specify that. That was quite a bit of work to make that thing work. And yeah, we could go in and tweak it more to get it perfect. I don't want to spend the time working with this much code to do that. So another approach we can take is to set it up so that we're defining our own layout logic to figure this out. Now, this is a pretty simple type of layout to do. We're going to have labels and text field, and we just have to compute how big the labels are so we know where to start the text fields, and then just place them. So let's go ahead and take that approach and see what happens. I'm going to come down to the bottom here, and we're actually going to create our first layout here. So I'm going to say form layout. And one of the things that's going to be passed in here is the actual content, which is actually going to be a composable function that we're passing in that has all the detail of what fields we want. So whenever we have something like the row or the column up here, this last lambda here is a content lambda just like that. If we control click on column, we'll see it. So we have content. He's a composable function. And in this case, he's passing in a specific scope to do the work for him. But let's come back in here and take a look at what we're going to do with this guy. So let's start with a layout composable here. And actually, he's going to need parens first. And he's going to start off by saying, what's my content? And he will actually be responsible for calling that content composable, which ends up running through all of the code that we have inside of it to create the different composable nodes. Now we're going to tell it where to place things inside of that layout. So inside of this block, we need to measure. That's our first step. That determines, whoops, let's see if I can get this right. One, measure. Determine the sizes of the components. And then we need to lay out, which places the components inside of there. Now at the very end of this function, and the reason we're seeing an error is because we haven't actually called that layout function yet. And we need to pass him in there. Oh, and he's also upset because I'm not passing in the right parameters. There's actually two parameters to this lambda. One is called measurables. The other is called constraints. I think that'll fix it. There we go. So that gets it so we don't have all these errors and have to deal with them all the time. So what we're going to do is we have to figure out the sizing of the components that we want and then the layout. And the way you set up your sizes is you're going to go to each one of these measurables that's passed in, and those measurables are generated from the content. So if you have 10 content elements coming in, you're going to have 10 measurables. And we're going to ask each of those measurables to measure itself, passing in some constraints. Now these constraints are the ones that are for the entire form layout, and they're driven by different modifiers coming in. So if you said things like fill to max size or fill to max width, fill to max height, those drive the numbers that are put in the constraints. And inside there, you're going to get four values: a minimum height, minimum width, maximum height, maximum width. And within those constraints, that's what you have to work with. When we're actually measuring things, we're going to have some modified constraints that we pass into them, because very likely we're not going to want to use the entire screen and say, hey, each component, you have the entire screen to work with. We're going to limit those somewhat. Now to start with, when we're measuring the labels, we're going to let them decide how big they want to be. And maybe later on we might constrain that up to a certain size. But let's think about that content for a minute. So the content coming in is going to have to be a mixture of labels and edit text. And what would be the most comfortable thing for the user to specify? Maybe label, edit, label, edit, label, edit, label, edit, just to have them alternate. So we're going to assume that they've set it up so that it's alternating label, label, edit, label, edit, label, edit. And we're not just limited to edit fields here, by the way. It could be another larger layout that's associated with that, associated with a label. So the first thing I want to do is let's just do a little double check here. I'm going to call check, which is a Kotlin function, passing in measurables.size mod2 is 0. Because I want to make sure that we have an even number of elements coming in, because we have pairs of things, a label for it, and then some kind of control or group of controls. If that's not true, I'm going to say form layout requires an even number of composables. So that's just a nice little quick double check there. Now let's split our list of measurables up into the labels and then the controls that we want to work with. So I'm going to say val labels equals measurables filter indexed, passing in a predicate here. And what filtered index does is it lets us pass in an index and a measurable. As an argument. And what I want to do in here is just say if n mod 2 is 0, that's going to be filtered in to the labels. Everything else is going to be ignored in that list. I'm going to do the same kind of thing here except with a 1. for, we'll call it controls. Now notice here that measurable isn't used. One of the things you can do in Kotlin when you have a parameter coming in to a lambda that's not used, you can replace it with an underscore to make it obvious that you meant for it not to be used. So now we've split those into two separate lists, labels and controls. And what I want to try to do is measure each of those labels. So the first thing that I want to do is set up a constraint that I can pass to each of these labels when measuring that allows that label to be a certain size. If we made this vertically scrollable, like that, then each of these guys could be infinitely tall. So what I'm going to do is start off with a var label constraints equals constraints. And then inside here, why is he not happy? There we go. I'm going to pass in min width, min height, and max width and max height. Let's figure out what these are actually going to be. So when you're talking about letting something be as big as it wants to be, you're going to set its min width and height to 0 to start with, and then have your max width and height be as big as you possibly can, up to a reasonable amount. Now, for the max width, we can't go bigger than the constraints max width up here. So let's go ahead and put him in like that. Constraints.max width. But think about that for a second. It doesn't really make a whole lot of sense to let the label take up the entire screen, because then we won't have the control visible. So what I'd like to do is pass in a couple parameters to let us know what we want our maximum size to be for the label part of the screen. So let's come up here and we'll say max label width, and we'll make him be in DPs, just so it's easier for the user to specify. But that means we need to convert from DPs to pixels. So inside of here, let's actually do it up outside the layout here. I can say width local density current, and all the width does is evaluate this argument and pass it in as this into the body. Once we have that, we can actually say val, whoops, and I'm going to say pixels. Let's just say px just to abbreviate that, equals max label width dot 2px. And that 2px function is contributed by that density. So we can actually use it in the max label width. So that's going to give us a maximum size that's actually a little bit nicer to work with. So let's nest all of this inside there, kind of like that. And now we can change this, instead of being constraints max width, we can have it be max label width in pixels. Now that max label width in pixels is a float where we need an int, so we're going to say toInt next to it. Now for the max height, because we're scrollable vertically, it really can be as big as they want it to be. So I'm going to say constraints dot infinity. That just says as much space as you want to use. So this gives us our constraints for when we're letting the labels measure themselves. So we're going to come in here now and take all those labels, and we're going to map them by saying it.measure label constraints. And whoops. Then we're going to assign that to something we'll call label placeables. And a placeable is what you get after you've measured something. So it's a measurable that's been measured and is now ready to be placed on the screen. So now we need to measure the rest of the stuff. So we're going to need to set up constraints for him as well. Let's bring him down there, and we'll call this control, constraints. And let's think about what his stuff has to be. So the controls are going to take up whatever width is left over after we've laid out the labels. So if we think about how much space the labels are going to take, the width of the labels section is going to be as wide as the largest label. So we're going to need to actually find the maximum width of those label placeables. We can do that by saying labels width equals labels placeables dot max of it dot width. And this will go through, take a look at that entire list of label placeables, which have had their sizes assigned during this measure process, and grab the widths, find the maximum, and return that as my labels width. So that's pretty nice. We can then say the controls width is equal to whatever our overall layout size is. So we're going to look at his constraints.maxWidth minus the space we needed for the labels. And we want to make sure that the controls are set to exactly that width, which means the min and the max are going to be exactly the same. So I'm going to say controls width and controls width. Now, as far as the maximum height, we're going to do the same kind of thing because we're in a scrolling situation. We're going to allow it to be as tall as it wants to be or as small as it wants to be. So those are our control constraints. Let's do the same kind of thing with the placeables. I'm going to say val control. Actually, let me just go ahead and copy that block. Be a little bit quicker. And change this to say control and controls and control there. And this should measure each of the controls to be exactly that width and as big as it wants to be vertically. So now we're down to the point where we actually have to place things. And when we're placing it, that's where this layout call comes in. And he's going to take in the actual width and the actual height that we're going to be set to. Well, the actual width, we're just going to take up as much space as, constraints.maxWidth. So we'll take up as much space as we're given. Now the height, we're going to have to make sure that we find out how tall everything is. And the labels that may end up being taller, the controls may end up being taller. So what we want to do is figure out the sum of all the heights of the labels, the sum of all the heights of the controls, and whichever of those is more, that's how tall our layout's going to be. So let's do that. Let's say val height equals max. And make sure you choose max taking an int and not a dp because it's in a different package. Otherwise, you're going to have to explicitly bring that in. So let's say label placeables, sum of. So we're basically stacking them all up. So we need to find out how much space they take up stacked. It.height. And then control placeables, sum of that. So boom, we now have the total height we're going to take up, which is either going to be the label column or the control column. So let's pass that in as the height we want to actually use. And now we get to place things. We're going to work our way down from the top of the screen when we're placing things. So I'm going to define a variable called y that's 0. I'm just going to update him along the way based on the height of each of the things that we've set up. Now we have two lists that we're going to work through at the same time. They both should be exactly the same size because we split them up. We can walk through these in several ways. We can set it up so that we walk through one of the lists explicitly using a for each index and then look up the other element directly from that. Or we can walk through just the indices and look up the individual elements. I tend to like to walk one list with the indexed option, use that index to look the other one up. Now we could create a function for this, and somebody probably has at some point, to walk two lists at the same time. I don't think it's really worth doing at this point. So let's come in here and say label placeables for each indexed, which is going to give us the index and the label that we're trying to place. And then inside there I can say val control equals control placeables sub n. So that'll give us both the items. We now have a label and a control, and they're the ones that match each other because of that index. Let's figure out how tall this particular row is going to be. It's going to have to be the maximum height of either the label or the control. One of them could be bigger than the other one. So let's say val height equals max of label.height and control.height. And we need that for two things. We need that to know how far down y is going to go next, and to also help us align things. So what we're going to do for the alignment is say val label offset y is equal to height minus label.height. And we're going to divide that by 2, so we'll just divide the space above and below. So what we're saying here is if the label is the smaller thing, we need to move it down a little bit so that it's centered. And we can center it by finding the difference in whatever the row height is and the space around it. Let's do the same kind of thing for the control. There we go. And now we can place these guys. So I'm going to say label dot place relative. And we start off with the x coordinate, which is going to be 0 because the label is right up against the left edge. And then we're going to say whatever the current y is for the current row plus the label offset y. Let's do the same for the control. It's going to be y plus control offset y. And for the x value, it's just going to be as wide as the labels column was. So labels width. Finally, we say y plus equals height to go to the next row. And what's it complaining about with height here? Name is shadowed, height. So we have another height available in the, did I specify height here somewhere? Yeah. We have this height up here. I'm specifying a new height. Let's actually rename this one to be row height, just so there's no confusion of which height we're actually using. That's a little bit better. And boom, we have a layout. That really wasn't a lot of code there to try to set up this little type of a form. And calling it is going to be even easier. So let's create a call to this one. Let's go up near the top. We will say form using form layout. Kind of like that. And let's start off by saying form layout. Max label width is, let's say, I don't know, 200 dp. Just a number that came off the top of my head. And it's something you want to experiment with to see what feels comfortable. And this will cap the size of the label. And depending on how you have a label set up, it might wrap or it might get truncated. So now we want to put our content in there. Let's see, where's a easy content to copy? This one actually, they're set up in the right order. So I'm just going to copy those and then get rid of the stuff that's in between. Paste them there. We'll go boom, ba-boom, 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 boom. Whoops, I killed the, yeah, that was brilliant. Let's undo that a little bit there. And let's try to not kill the part that we actually want. There we go. And that should be really all we need for this definition of the form layout. That's kind of nifty. Let's see if this one's going to work for us. And I'm going to run this. And here's our new form layout. Now, obviously, I used the one that doesn't have the outlines around it, but notice how everything's lined up really nicely now. And we have a little bit of spacing around each of these guys. Vertically they're lined up. We have space left at the bottom. Let's see what happens when we rotate the screen. So now I have a scrollable version of this, and that works pretty well. Let's see what happens if I make one of these labels a little bit longer. Let's actually say first, let's make it be the last name. Ooh, look at that, it's actually updating on the fly. This is set up right now so it's actually live updating when a constant changes. It can't do this for a lot of things, but sometimes you'll see this happen. But this is actually a fantastic place to see it because you see it's actually wrapping, and that row is getting bigger to allow us the spacing for this, but the two of them are still staying evenly centered. So that's pretty nice. That's actually working well. And if I come back here and change back to last name, boom, everything's just fine. If I come up here and change the size of the max label width, you'll see that it actually wrapped these guys, but it's still keeping everything nice and centered. So this is an example of creating your own layout to do something that, all these other versions was quite difficult. It didn't take us a lot of work to do this. So consider that when you're setting up some code. If you have something where it looks like your layout work's going to be a lot, but the algorithm seems kind of simple to actually implement it on the screen, think about creating a custom layout. So I do actually want to go into this edit and change him to be an outlined text field because I just like the look of that better. And now if we run that, notice I'm going to have to rerun it because it didn't show up on the screen. We're not just changing a constant in this case. And there we go. So that's actually pretty nice looking. And I wanted to change that back to 200 like that. Let's think about this layout for a minute here. If we don't have enough room for it really to be comfortably side by side, it's going to look kind of messy. It's going to be really hard to deal with. So what would be really nice is if this form layout was able to make a decision on switching between basically a column layout view of things and this form layout view of things, depending on how much space is available. So let's update our form layout to do that. So the first thing I want to do, let's go down to the form layout, is I want to pass in a constraint here to say what's the maximum size, or sorry, what's the minimum size I want to use to have this side-by-side approach taken up here. And this is a little different than what we did in the other one where the entire screen was dependent on if it's wide enough. This is actually a component that may be inside of a bigger screen. And if he has enough space on that bigger screen, the component itself would be deciding if it wants to actually do side-by-side or not. So let's add in here a min width for side-by-side. And we'll do that in DPs as well. And then we can do the same thing here, pulling the pixels out of it. Kind of like that. That'll give us that type of setup. And what I'd like to do is when we're setting up this screen, we're going to either do this layout or we're going to do a column layout. So rather than actually use a column layout, which I could put an if around this layout and then the else just use a column directly. Instead of that, what I'd like to do is actually lay it out explicitly so we can see another example of how the layout algorithm works. So we're going to do it inside of this layout instead. Let's think about, first of all, if I wanted to put it outside of the layout and actually use a column directly. What I would have to do is I need to know the actual constraint size, so what the maximum width is, to determine if I'm big enough before I can choose a layout or a column, which means I need to know at this spot out here, and I don't have that available to me yet. So in order to do that, what I can do is add in a box with constraints. And this passes in this box with constraint scope, which tells me the constrained width and height. So it's going to tell us how big this guy is going to want to be. And inside there, I can say if max width, because he's going to have the max width, max height, min height type thing. So if max width is greater than or equal to the min width for side by side, then I'm going to do my form layout, else I'm going to do my column. So if you wanted to do it on the outside and actually take advantage of column, which is a good idea, you could do it that way. But I'm not going to do that. That's just a little note to say box with constraints is there to give you that visibility early on So you can make decisions inside of him if you want to do your custom layout or not. But since we're actually doing our custom layout, we have these constraints available. We can actually check them inside of here. So let's give ourselves a little room, and we'll say if constraints dot max width is greater than or equal to min width for side by side px, then we're going to do all this stuff. Else, we're going to do something a little different. So let's go through another layout algorithm here. And this one's going to be really, really simple. Let me throw in a dummy layout down here just to get our error messages out of the way. We're going to start off by saying val new constraints equals some constraints that I'm going to create here. And we will pass in min width. Whoops. I guess min width, max width. And then we'll put in the heights here. And let's figure out what these ones are going to have to be. This is actually pretty simple because we're just laying these out vertically. So they're always going to take up the full width. So we'll say the incoming constraints, max width. And the max width is that max width as well, which should fix them to the biggest space that we have available wide. And then let's think about the height. The min height, we're going to start at 0, but because we're inside of a scrolling, he can be infinity tall. So constraints.infinity. There's our new constraints. Now, the measuring cycle is really easy here. So we're going to say placeables equals measurables map it.measure new constraints. Boom. That's going to do all our measuring for us. So it's going to walk through all the measures, convert each one into a placeable, and then return that list to us. Boom. So now to figure out our total height, because we need to pass that into that layout call, let's say val height equals placeables sum of it.height. Just walk through them all, add them all up, and now we have a height to pass in. The width is going to be that same width that we've been using all along here, that max width. And now we need to walk through the process. A little bit similar with a y. Say y equals 0 to start with. We're going to walk through each of the placeables. And we'll say it.placeRelative. They always start at the 0, and they're always at y, and then y plus equals it.height. Boom. And there we go. So this, if we took a look at how the column is implemented, it's very similar to this type of approach here. We wouldn't be, normally with a column, you wouldn't be setting up the max width, the actual stretching stuff that's driven by the modifiers. But for our use, defining this form, we want them to always stretch. So this is basically what a column does behind the scenes to set things up. But now we set it up so that depending on how much space we have, we may stretch or we may just do a column. So let's come up here. We'll see that this guy's not happy because we're not passing in that min width for side by side. And let's say 700 dp like we were doing for the normal screen type thing before. So if we have at least 700 dp, we should see side by side. If we don't, we should see just a vertical list of things. Let's see how this actually looks. So we'll run him. And now we'll see on this screen, this view is showing us label, field, label, field, label, field. So it's basically the same as we're doing a column. Now just a little note on scrolling here. You'll notice that there's no scroll bar on the side. And this is a known bug in Jetpack Compose. They're working on it. I wish they'd work a little faster because it always bothers me when you don't see a scroll bar because the user, taking a look here, really doesn't know that they can scroll to see the zip code. If there's a scroll bar there, then they know that there's more down there. But unfortunately, the way this is set up right now, there's no visual indicator. If we go side by side, now, or if we go to landscape, now we'll see that there's enough room to do our side by side. We have that nice looking layout there. So this component now is making this choice, and it was really easy to write. Now I know I worked through the math a little fast on it, but if you take a look at the code, it should make some sense on how that's working. But it is actually fairly simple to write this layout. And if we looked at the old ways of doing things in Android, whew, boy, that was a lot more work to set up a layout. One gotcha. When you're defining your own layouts, you're only allowed to measure once. And there may be times when you want to pick alternatives based on what your children are telling you. So you'd want to go down and measure them to see how big they are under certain circumstances, then try a different circumstance. You can't do that in Jetpack Compose. And they made that a design requirement because they don't want to get into the same situation before where you could have this constant up and down the stack of figuring out of doing all these calculations, which could really slow down the layout. If you do need to do something like that, you can actually take a look at the intrinsic sizes of components. And what an intrinsic size means is, what is my natural size? So something like a label would just be the size of how big it takes to display the text on the screen. And you don't get to pass a whole lot of constraints in and things. So you could ask that. I'm not going to go into that detail here. I personally haven't had it come up yet, but at some point it may. If you're really interested and you find yourself in a situation where you need to go down deeper, make sure you take a look for intrinsic sizing.